Okay, before the break, we were looking a little bit more at uh, object-oriented stuff. We'll talk about that. I'm expecting the rest of the next part to take about 15 to 20 minutes, somewhere around there, and then we'll look at using databases with that, and we should still be out at a reasonable time, but if we don't get to the database stuff, we'll push that assignment back. Next up, in many of our object-oriented programming languages, we have a special type of object known as an interface. We don't have interfaces in Python, but the word itself, interface, is a point where two systems interact. Or as a verb, just means interact with another system. So a graphical user interface, GUI, or often pronounced GUI. That's where a human system, the brain and hand, I guess are the key components, the brain and the hand controlling the mouse, interfaces with application level software. A USB type A interface. It's where an external computer system, flash storage, a dongle for a mouse, something like that, interfaces with an operating system by means of the hardware. Interface in software is typically introduced with the idea of a set of rules an object must follow, like a list of rules. But basically what it means is we'll have a bunch of methods, but we don't have any code. The methods don't do anything. We just have the names of some methods. And when we implement that interface, we're required to finish out those methods. In a payroll example, a payroll calculator, we would need to calculate taxes, but we don't know how to calculate an employee's tax ahead of time. We just know that every employee is going to have a method to calculate their taxes. So our interface, our rule, is that we have this calculate tax method. We implement that interface, and anything that wants to behave as an employee object then is required to have that. Is required to have that calculate tax method. So it's the virtual version of a shape, just like a USB plug has that specific shape that anything that wants to interact with computer systems via USB port has that exact same shape. There's Star Wars, the way R2D2 could get into any computer system because there was a standard interface. If it wanted to be a computer system in the Star Wars universe, it had to be round and spin around, and the little thing all the mechanic droids had plugged right into it. A standardization, and we use methods for that. We write out the names of the methods, kind of like that one that's in our example. We'll go back and look at in a second. That make sound method. If anything wants to be an animal object or a child of an animal object or interact with the animal object, the one guarantee that we're going to have is that it has a make sound method. But in our parent object, where that's going to go way back up at the animal level, not any of the child classes where we add details, we don't know sounds of detail. We don't know what's going to go in that method. We just know that we're going to have that method. So that's if you want to think about it, you can think about it as that's the shape that it takes to plug into our object, that make sound method, when we get to our example. A list of rules, but yeah, kind of like, think of it as akin to the physical shape. So like on your monitor, the either HDMI or VGA, however the monitor in front of you is plugged up, there's a standard way so that we know anytime we have a monitor, we can plug it up to that tower, and we don't have to go take 5 or 6 tries to figure out what sort of cable plugs up that monitor. There's two, really, we're moving towards one, but the most recent one hasn't phased out yet. We haven't completely phased out the other one. That's the only reason there's still 2, but soon it'll be all HDMI or HDMI micro. So I guess there's really not one. There's varieties of every standardization. So obviously usefulness is when other programmers are going to be using software that we wrote, we want to make sure they implement methods in their objects that will work with ours. So we want to, like the physical plugs, we need to set up that shape so that the things plug together and work correctly. Just the software version of it. In C family of languages, we cast objects into our interface. So instead of using their own type, we change the type. We see casting in Python, right? Cast an integer into a string so we can concatenate together a string, or cast a string that we get from the keyboard input, the input method, cast that into an integer so we can do math with it. We can cast things into an interface in particular. So maybe you're working with a decent mid-sized application, like 75,000 lines or so, and will you remember what you were doing 6 or 9 months earlier? Probably not, right? Oh, and I don't think I talked about that number. I just threw out a number there, 75,000, just random. I have had things that were, I pushed 20,000 lines and still called something a small program. And I've also had 115 lines that I called a big program. So the line number does not relate, small and big relates to the difficulty of it. 115 one I'm thinking of was it was a final project in my graduate studies at Indiana State where I had to actually plot a dynamical system. I plotted the Lorentz system. I had to actually plot chaos. Only took 115 lines, but that's hard. That's not like taking a bunch of inputs on the web page and sending them to the database, even if that grabbing inputs from a web page and going to the database took 20,000 lines. None of those lines were very hard. Plotting the Lorentz system, which is three-dimensional all in imaginary numbers, or at least like six-dimensional thing. Six-dimensional chaos is plotting that every single one of those 115 lines was really, really hard. So big and small aren't necessarily line numbers. How hard is the problem? Right? Because some problems are obviously much, much harder than others. I like to point that out somewhere on this level of class 2 because it's not necessarily line numbers that mean a program is going to be big, or when you go to charge the client, it's not necessarily estimating the number of lines that you're going to write. How difficult are those lines going to be? Keep that in mind. But anyway, it's a set of interface like a set of rules. And we can take that a step further than interface by implementing what's known as an abstract class, where we have a full class, a design for an object, except some of our methods we can't quite fill out. And we do have that in Python. So we don't have interfaces directly, but we have abstract base classes. So really, if we left off the data fields on an abstract class, we would basically have an interface. We'd have a bunch of methods that aren't filled out. So I want to inherit from a class ABC. Is it lowercase? Oh, I have to import it, don't I? Import ABC. And then we are just going to inherit from that ABC class. Stands for abstract base class. And now we can have a method that doesn't do anything. Not quite yet, we have to do something. Let's look up the syntax for it. I like to do that occasionally. I used to always do it from memory, but doing it from memory comes from years and years and years and years of doing it, followed by years and years of teaching it. So doing it from memory is kind of deceptive because, I've taught this class a number of times. It's not the first time I've given this lecture, which is very different than trying to remember it. So ABC in Python, probably pull it up. I already know the name of it. ABC, abstract base class. Remember my tip earlier? Always look at the official documentation first, because that's the user manual that stays up to date, changes. Tutorials will go out of date, and tutorials only have an upper limit. Tutorials only introduce stuff. So we introduce a class, blah, 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 a bunch of stuff here. These are going to be, we can do assertions. I'm not really getting into that part. So we have abstract annotations in there. An abstract class methods, so I have annotations, but the official documentation is kind of hard to follow, right? But always look here first. That's the user manual, and use the tutorial to learn to make sense of the user manual. That will go a lot further. So let's try this again with something useful like Geeks for Geeks. Geeks for Geeks has great stuff. They're up there at the top and probably really easy to follow with a super simplified example. Since Python often shows up in middle school these days because Python's often used in programming robots, and middle schools when people start programming robots a lot, even before they've had algebra classes, so they're not doing the calculations. So notice we have a class, an abstract for function says return none, and then this register that. But notice how we're not really doing anything with that function. Is that the example I wanted? Here's the one I wanted. So we have this abstract class, and the inheritance isn't just ABC. So inheritance is abc.abc meta, so all of our metadata, and then we can start doing things with it. This example has a list. Is that the one I'm looking for? I was looking for a simple method. Is subclass class method? Ah, here we go. Abstract method. This is the one I was looking for. So we inherit ABC meta, and from that we'll do add ABC abstract method, and then our method doesn't do anything, and they don't show any further of it. But then in the child classes, we'll use that. So let's look at our example there. Oh yeah, and then go back to the documentation and try to make sense of what this was saying based off the easy to follow tutorial. Make sure you're looking things up that way. But what we're going to do is copy that from that example. We're going to have an ABC abstract method. So we'll copy that over here to Spider. I'm going to say pass. Whoops. Put my fingers in the right spot on the keyboard, and we'll say pass. Our method doesn't do anything. That's the abstraction. Oh, I guess I better do all that other stuff, right? With this part, and you may see a problem with the way I'm doing this right here. It works. This code's going to run. But
is it going to pull more information than you need?
I don't know. Like I was just what I was looking for. Yes, it will. You're correct. It's going to download that whole module and download a whole bunch of stuff, but it will ignore that come runtime. What I was looking for is I didn't really learn anything copying those over. All I learned next time I need to do that, I'm going to have to copy and paste from the same spot, or find a different spot that I can copy and paste from, right? So at least manually copy and paste. Put your fingers in action and retype the same words. That way you've seen them at least once and thought about it, but hopefully that's obvious enough that it makes sense and you didn't need it explicitly stated. But after years of teaching software development, I like to explicitly state that. Does their example go on? They don't make any subclasses. You know, we have properties and all sorts of abstractions we can use. Well, they don't make any subclasses in their example. Well, they didn't finish it up, but you don't know that part, but I like to do it occasionally here. And keep that in mind, like that clear clears what I was typing. That copy and paste thing, at least type it in. Typing's easy, and you want to think about what you're typing, especially in the learning environment. So now we have this method. So there's no errors when we use it here. We wanted to make something with that. It's a good name for a fish. Nemo is an animal object because we don't have a fish subclass. It's abstract. We can give it a name. Nemo, 1 year old and weighs something like that. Nemo, but it doesn't quite work. Those the text editor didn't notice any problems, but we got a runtime error. We can't instantiate an abstract class. We have an abstract method. We're going to need that method later. We don't know what it's going to be though. We'll fill it in later. Basically, that we have it. But abstract and concrete are the keywords to take away from this. We can only instantiate concrete classes. Which we have to make our subclasses concrete now. That's the only part. So lion, we can't just pass on that because it's a child of animal, which is abstract. So we inherit everything it means to be an animal. But now that we have a lion, we do know what sound it's going to make. So we can turn that abstract method into a concrete method. Make sound itself, and we know that the lion roars really, really loud. The cat, well, we already have the make sound method. So now those are concrete because everything else, we knew exactly what it was going to be when it was an animal. Dog, already has make sound in it. So I guess it was just lion that needed to change. But we can't make a generic animal. So now all of our subclasses have to be specific. So if we needed a fish, fish inherits from animal. The constructor's good. The fish is going to have a name, an age, and a weight. Fish is going to really hate being weighed because we have to take it out of the water to do that. It is something that can be done. Make sound. I don't know. Oop. Does that sound like a fish sound? A bubble popping sound? Splash. Loop. Some random noise that a fish would make. And now we can say Nemo is a fish and should be okay here. So concrete and abstraction. And on our UML class diagrams, the symbol for abstract is whatever you want to call that. The pound sign, number symbol, hash key. Lots of words for that symbol. The thing above the 3. Lots of words for that symbol, but that in our UML class diagrams represents abstract. Means we can't instantiate that class.
Octothorpe.
What's that?
It's an octothorpe. The hash symbol.
Okay. It's also called that. There's lots of names of it. It's a tic-tac-toe board.
Yeah.
Yes. What she said, octothorpe, 8 spaces, which seems to be 9 spaces, but only 8 of them are open. 8 openings. Not space. 8 spaces and 1 close. So 8. Yeah. Lots of names. I almost never say the 8 one because there are clearly 9 areas there. It's a tic-tac-toe board. It's 3 by 3 grid, but for some reason 8 isn't the official name of it. All right, that was the basic idea of abstraction. We will see it more after we talk about data structures coming up soon and start making our own list and heaps so that you can see that a list is not some super complicated thing. You have to be a master programmer in order to create a list. Is just a data field in an object that says that points at the next thing. Usually we call it next, and yeah, it just pointed the next one, and then we just loop through things. We'll see that soon. Make our own list, and you'll see that it's actually a very simple thing. Lists are already built into every language, so we'll probably extend that into a stack and a queue. We'll talk about heaps. We'll want to look at binary search trees, but some of the things that we can do better than just the generic list that's built into the Python language. When we know what data we have and how we're going to process it, we really should optimize those things. We really should put it in the best type of collection we have for that sort of data and that sort of processing, not just random lists that came with Python that has every that has that huge list of things, huge can't say list, huge amount of options, right? So append, extend, remove, all those things that are built into the list in Python, that's overhead. If we don't need those, that's extra data eating up RAM, which seems small, doesn't seem like a big deal, but think about big data, right? Amazon's database probably grows by 1 billion rows in the time it takes to say the sentence. Amazon's database grows by 1 billion rows, right? Modern data sets are huge, so it does add up. So if we can cut it back, make our own list, because it's only one data field in an object, make our own list and use only the functionality that we need, we don't end up with that overhead.
We open the string statement of animal object.
Do I have WordRap here? I've never tried WordRap. Let me open it in Sublime so I can turn on WordRap. There we go. Oh, zoom. There we go. There it all shows on there. And that is just WordRap. I have it typed as a single line. If you want to do line breaks, you need a backslash. Has everybody seen that before? You leave. That's probably gonna be confusing. It is just WordRap on there, so that should be typed as a single line, not multiple lines.
And mine was showing error because I didn't put parentheses for get name and get age.
Oh, okay. Yes, they are the method calls themselves, not a callback. Because the computer will not get to this line of code until we call this method. Versus like in Django, where we would just pass in the method name, that goes into another list where it's going to be asked for later. The computer processes it before it runs. Does that make sense? The computer sees it, it runs it through, takes it out of RAM, runs it through the CPU, and does all the processing, but it's not ready to spit out the output yet. So it has to wait on it. So it gets so it goes all the way through it like it's gonna, but then stops right before it spits out the output and puts that in RAM, so that when it is ready, it can grab that already processed one and just do that last spit out the output part. That's kind of what a callback is. But here we are actually running the method, calling the method. So that's when we want to use the parentheses.
Why did we change it from name to get name?
Child objects inherit that. We will see that more in our in later examples. But child objects inherit the methods, but not the attributes. So let's put it age back.
Oh, because yeah, the same thing with C, because the attributes are private and methods are public.
Yeah. So yeah, and using parent-child relationships, children don't have access to all of their parents' stuff.
Yes.
So it's kind of like that. We have access to some stuff, but not all of it. So if you want the child object to inherit it, go with the methods. That's pretty much what I had to say about those. Any questions? Because we are going to come back and see these later. And yeah, then we would probably make sure you put your guard statement in, and then we'd import that in order to use it. So I'll create a new one here called zoo.py, the actual script, and we want to import animal, and then we can say over here is where we would do all of this part. Fido equals animal.dog class with the name equals Fido, age equals 3, like a puppy, weight equals 38, and bandana equals true. And then Fluffy is an animal.cat named name equals Fluffy, age equals 14, and weight equals, I have no idea how much a cat weighs. 8 pounds?
Yeah, that can be.
And then this is our actual application where we're using it. And down here we'd say like print Fido and print Fluffy, but that's probably not where we would probably do something more interesting than print, right? Oh, whoops, let me fix that typo. Which actually makes a really nice segue into the next thing. Where's the typo? Oh, capital F. Fido and Fluffy, and then this is the application where we use it, or somebody else can download this from GitHub and use that in their project, and that way they don't have to make an animal object. That's the idea of open source. There's no need for all of us to start at scratch, because if we all have to start at scratch every time, we don't get very far at all. So that's that class that's going to run in the fall, the special topics. What number did I give it? I think I put 193. That's an old numbering system. From when there was only 14 campuses, Sellersburg was 13th campus. So special topics go from 181, with 1 being Indianapolis, and then it like spirals around the campus, and then Sellersburg is right near the end, and then Evansville, if we spiral around the state clockwise, is where how they were originally numbered when there was 14 campuses, but now there's 19 campuses, and each campus has several sites. Like here at Sellersburg, we have 3 sites. Anybody live out near Austin, Scottsburg? We never run classes at our Scottsburg campus. I want to start running maybe SDEV 120 or Informatics 109 out that way. And when I checked the database, it looked like there was enough students in that area: Salem, Austin, Scottsburg, north of Charleston, where there's not any towns. I guess North Vernon's up there somewhere. But a lot of those people drive a long way to get to Sellersburg, and we have space in Scottsburg, so maybe some of the intro classes. I'd like to start doing some of those out there, but I want to get feedback from people that live in that area first. Let's see if they would like to do that, or they just prefer to drive into the metro. It's not a bad drive. You jump on the interstate, and speed limit's like 80, 85, something like that. You can get there really. It doesn't take long. Yeah, it's 70. It's still pretty quick to go 20 miles, but if you can save 10 miles, or save 20 miles of driving, anyway, it's a different point. So it's something I've been doing for analyzing the database here at Ivy Tech, and trying to think of ways to things to do with the program that would be beneficial to students. A lot of people live out that way, but it is kind of a community, so it's not massive amounts of people. But we do something like this instead of printing it. Probably work with the database, load it into the database, or I pointed out that these are called data fields. We had the DBMS 110 class, and remember when we set up our rows in a relational database, each column in the relational database is called a data field. They look very, very different in the text files where we're typing them up, or the SQL or Python code in this case. They look different, but we call them both data fields, and it is not a coincidence. So internally, not necessarily different, beyond the program is in RAM and the database is in storage. So there's a connection there. So the next thing we want to look at is databases. So I'm gonna move on to that. We're going to come back to objects a couple times because objects are a big, and yeah, objects are going to show up basically everything you do in programming here on out. Even if you go all the way to the doctoral level, you're going to be building on object oriented programming, because once computers could handle that extra overhead, we never look back. The thing we get to think more like a human. When we design our classes, we still have to do that computer logic in order to turn it, to reorganize it into something so we can think like a human for the rest of our program. It makes everything a lot easier. So let's start a new one here. There's a couple databases we could use, a lot of options. Obviously, we're programmers. We tell the machine what to do. We could tie into MySQL database anywhere in the world, put it on a server and tie into it. Oracle SQL, Oracle MySQL, or when the guy made MySQL, he made two of them. He named them after his daughters, Maya and Maria. Maya's the one, proprietary one. Maria is the open source free one with more functionality and easier to use in a lot of cases. I always thought that kind of made a reflection on, wonder if that was like a reflection on how he felt about his daughters. But anyway, that's a question for them to address. But there were two MySQLs, open source and the proprietary one, a SQL Server, all sorts of databases. Then we get into Postgre stuff, local, remote, lots of options. A very, very common one in programming, we have it in lots of places, is SQLite. So SQL, structured query language, if you haven't heard that before. If we can pronounce the acronym, we try to, because it's really rough talking in all words. And there was a phase that lasted about 8 or 9 years where people would think of the acronym first and then come up with words that fit the acronym. We ended up with some really odd ones. The forebearer of that was Twain, technology without an interesting name. The original Java package manager was Ant, which was another neat tool. But they thought of the names they thought of how they wanted the acronym pronounced, and then came up with words that describe their software to fit the acronym. Which I guess some people still do that, but it's something that exists. So SQL is hard to talk in letters, so if we can pronounce it, we try to. And generally it's okay to pretend like there are vowels in there, just to make it pronounceable. That's a structured query language. It's for relational databases. And in particular, there's one that it's included in Python programming languages. It's compatible with just about all of our programming languages. Google, if you want to do anything for Google, any software that you want Google to even cooperate with, SQLite is like an interface. You better have SQLite in there if you want to interact with Google software. So let's look at SQLite homepage, or some people go ahead and do SQLite. Depending on how you want to say it, it's an acronym. Structured query language, IT. But C family library, but it has been ported to any programming language you can name and probably more. Has everybody ever looked at the list on like Replit.com? Am I not signed in? Let me sign in. Go to create, and we just start scrolling, and it's an infinite scroller. The further we scroll, the more programming languages show up to scroll through. It starts with the ones that it thinks we're most likely to use, but Yeah, it's an infinite scroller. The more we scroll, the longer the list gets. So it's been ported to more languages than you could probably name. Because another common thing is people will make the programming language they need, not just the program. They'll make a programming language optimized for the program they're going to make. That's another thing the software developers do, right? So those teams of 30,000 people, 10,000 of them make a new programming language, and then the other 20,000 learn and use that programming language because it's optimized perfectly for the thing they're going to make with it. If you, as big as Google is, this is almost like an interface for Google. We just talked about interfaces. Your stuff better be compatible with SQLite if you want to do anything with Google. But it's small, fast, self-contained, highly reliable, fully featured SQL database engine. So all the stuff we want from a database, small. It's not remote. You'll notice remote is not on there, so we wouldn't put it on a server somewhere. This is usually goes with the program we're creating. That's why it's available in almost every language. And then the next line. Stable, cross-platform, and backward compatible. Those all sound really good, right? And the developers, people that work on this, pledge to keep it that way until 2050. And 2050 is not when it ends. 2050 is the next time they're going to evaluate backward compatibility. So in 2050, they're going to decide how far backward that compatible is going to go. So some really, really good things about this, right? It's often used and it gives us the speed and reliability, performance, and organization of a relational database in our software, built into the software application we're creating. So really, really good one, and it takes a flavor of SQL. So if you've seen SQL before, there's some slight differences. One of the words probably going to show up here. Auto increment is one of the words I look at because that's one of the first ones that's different in every flavor single SQL. Are we in Oracle SQL or are we in SQL Server? Are we in MariaDB? That's the first word I look for is auto increment, because is it two separate words? Is it jammed together as one word? Is there an underscore between them? And that's the first clue as to what flavor of SQL might be looking at in a particular case. Because SQL is a family of languages, not a single one. But let's look at SQL Server. So let's come back over to Spider. Import SQLite 3. Notice we didn't do pip install, so it's built in there. And that's a lot to type, so I'm going to do SQL. Let's simplify it a little and we'll just type, rename the module.
Still upset?
It's unused, so that's
Okay,
that's the refactor. It's imported but unused. Sometimes IDEs are really, really quick at looking for refactoring things. This is built into the database, so we would just I'm looking up an example. Because again, it's back to that point. I'm trying to do this less of like looking about doing it from memory, because right, if y'all are seeing this for the first time or maybe even the second or third time, it's me doing it all from memory is not very descriptive because I've taught this class more than once. I've taught other programming classes too, and this shows up in just about all of them. So the only time I use a different one is when I teach the Java class, because then I use a MySQL. I do go to a remote one from Java, because if we're learning Java, Java is for big things, Python's for small things. That's our general rule of thumb in modern world. If it's big, it's Java. If it's small, it's Python. There is a slight preference in the Louisville metropolitan area for C#, but over Java, but there's no shortage of both of them, and they're very, very similar languages. So if you know one, the other. So I guess I should say it that way, because in the suburb, for those elsewhere in the state, Sellersburg is a suburb of Louisville, Kentucky. So our three big employers around here, for software development are going to be Humana, UPS, and Yum. Those are the 3 companies in Louisville that hire programmers, like hospitals hire nurses. Not that they're dream jobs or what you would want to go for, but they pay really well, and they hire programmers like hospitals hire nurses. Okay, so I'm going to look at last time I taught this class, SDEV 220-spring 2023. So this is another point, right? Earlier when we did the lookup example, looked at documentation, tutorials. What's even better is looking at your own code. So keep trying to organize stuff, because when you look back at your own code, it's not just getting that one line. It'll stir up memories of everything that was going on at the time you wrote it and help you remember even more stuff. Do I have that on? I'm pretty sure I did database. Yeah, update structures. Wait. Surely I did databases last there. Generate dimensions. Go back to 2022. What about when I taught this class 2 years ago? Set up record. Set serial. Parallel odds and ends. Well, I was trying to make a neat little point there, but I know I've taught databases in here. It was in April 5. Directory, nope, that's operating system stuff. Blah, blah. Appears to be a list. Bunch of 2s. I remember this one. This was on February 2nd, 2222. Nope, that was an example. Well, I was trying to make a point, but I apparently didn't label the folders very clearly. That's stuff 23. Oh, that's the phone. Not it. Well, it would have been nice if I would have organized this. Maybe I do need to go to the other ones. The transfer data. Nope. That is transferring stuff. Testing sets, serial.
Data structures.
So data structures are stacks and heaps, and data structures are in RAM and databases are in storage. Is our quick rule of thumb. Maybe it is though. This link stack you. Yeah, we're going to build all these here shortly. Okay, well, apparently that wasn't a good place to look for that example because I didn't name anything correctly. And the last 2 times I've had taught this class, I'll have to dig intently through the folders. So I'm also going to go over here immediately and go save this in a useful name. So in the repository, I'm going to create a new folder called database. And this is data.py. All right, that's a good name this time. So let's look at. So I guess sometimes that method doesn't work if you're not very poorly organized like I am. Create table SQLite. This is probably what you're going to do. You can go over there and look for that explicit thing, right? Oh, here's the create table thing. So what do we do? Oh, pictures, descriptions, blah, 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 a bunch of stuff. Where's the code that we copy and paste? Oh, here we go. Create table. You're going to look through it like that, or tutorials point. They are good stuff. Looks like they got a bunch of things. I don't see any examples though. Connect and SQLite. I'll just go through it in order. First thing we have to do is connect or create our database. Connect in SQLite. Great. There we go, right to the Python docs. This has examples, I know. So we import it and we create a connection and then give it a name. Fairly straightforward, right? So we imported it, renamed it SQL. So we need a way to reference our connection to the database. Connection is SQL.connect. I don't know what it is. Close that one. Look at this one. Yeah, connect. Okay, predictive text is giving me something odd. Be careful not to trust predictive text. It's not coming from an AI, which still isn't intelligent itself. And we need a name for it. So this is inclass.db. And file extensions are arbitrary, but if you give it the .db file extension, your operating system will know what to do with it, which is kind of important. So for your databases, you do want to it's one of those cases you don't want to go off on just arbitrary file extensions, though it would work. And then our example, right? We continue through the user manual. Then we use the connection to create a cursor. Y'all know what a cursor is, right? Everybody's kind of familiar with a cursor. I let that word hold shift and push over. I'm moving the cursor and using the cursor to read the words. So we just need a virtual version of one of those. I'm going to spell it out. Cursor is that connection we created. Dot cursor. Which again, well, I pulled it up eventually. And cursors are always the same. And now we can do things with that cursor. Yeah, that's the key points. Now we can cursor.execute. So execute a query. Create a table link query. Cursor.execute a select query. Cursor.execute a different select query, a more refined select query, or cursor.execute an insert query. Do you see a pattern forming here? And there's a whole bunch of them. Oh, I was getting ready to scroll down to look for this one. Then we have to commit to all those things. So the cursor is kind of like a file handler in that it sees the database. It's the thing that can see the database. It's like, oh, there's this stuff. Run this select query. Oh, I see all that. See all the data you wanted. But we don't want to accidentally mess up our database. So it can see it, but it's not going to grab it with that select query until we commit to it. So then we do cursor.commit after a bunch of queries. Then we run more queries, and eventually there's close. Is that not in here? Oh, there it is. Then we close our. Well, that's bad form. The user manual does it backward. The user manual skipped line, and really we should close the cursor and then close the connection. But if we close the connection, obviously that's going to delete the cursor at the same time, right? Just like if I have these words highlighted and close the web page, that cursor is gone. So I guess it's okay to do that. The order matters, right? We open the connection, then open a cursor. So later we need to close the cursor before we close the connection. Yeah, that's our format. Then here, run a bunch of queries. And then down here, I'll just do like they did, connection not closed. That'll shut down all the parts of it. And then these are just a bunch of structured query language queries. Everybody know the difference between a question and a query. Questions are open-ended. Can I get a lunch at Taco Bell? That's a yes or no thing, right? Can I get lunch at Taco Bell for under $6? Right, open it, pull out the wallet. Can I get lunch at Taco Bell for under $6? There's that criteria. So it's not just a simple yes or no. There's conditions have to be met. That's a query versus a question. A few of them that will common ones. So let's do a
When
create.
you declare a cursor that's open the database.
So connection opens the database,
Oh,
and then cursor starts digging through the database. So connection opens the database, and cursor is what can reach in and do stuff with the database. That makes sense. Because there are other things than cursor. That page is really, really long, but we don't need to get into those in a 8-week, 200 level class. It gets more advanced as you go down. So eventually there's people in graduate level, 600 level computer science classes. The things way down at the bottom of that documentation page you were just looking at her. There's more that it can do way down there. So we just need that top run queries. So our queries look like this. So let's create query. And we pass them in as a string. SQL is not case sensitive for the keywords. It is case sensitive for the words we create. So we'll like, this instruction is we want to create a table. So I want to create table, if not exist, because that's a problem. Right. The first time we run this code, we're going to create the database. In other places, SQLite kind of handles a lot of it in the background, but in other databases, we don't want to try to create a database that already exists. So we want lines like this. So like the table, create table if not exist. Those are all keywords. Those are not case sensitive, but now we need to give that table a name. My standard classroom example is people with name, age, and town. I'll do it in Pascal case. It's good form. Pascal case on table names, camel case, and field names. And we'll do name, age, town, nothing too fancy. And then SQL ends with a semicolon, which in our other languages can be a problem because there's a semicolon for SQL, which means end of instruction, and a semicolon for the programming language, which also means end of instruction. So all our lines end up with 2 semicolons. I'll be right back. Yes. Oh, okay. Everybody joining me still? There's got to be something there is. So I appreciate you doing it. It's still walls. Otherwise, people start walking over. People will pick it up quick. Appreciate it. Let me know if you have any trouble with classes. Sorry for the interruption.
I apologize to interrupt you.
Oh, no, I was expecting it. I'm giving her something to think about it for a moment. And copy code. Oh, and we just had reference material lookups. All right, sorry. had to talk to him real quick. His class ends an hour earlier than ours. Actually, our class is gonna end in about 15 minutes because we just have to type a couple queries. How many people have seen SQL before? I have already got questions because some people haven't seen SQL before, haven't seen SQL syntax. We just need some very basic stuff. So even if your project is very database heavy, it does not have to be an optimized database. You do not need to normalize your tables. Not need just we're under tight time constraints. So even if your project is almost entirely built around a database, it doesn't have to be a great database. Just a database that exists and there's some data in the table and you can retrieve that data and work with it. That's good for our class. Right, this is one of our major learning objectives, but our course is about Python. So we don't need to get super in depth with SQL. This is what, right, you're going to want to create a table so you can put your data into it. And tables need things. So we can't just say table. We need not like an ID. That's important for data. So we'll have integer primary key, auto increment, which I think this is wrong for SQLite. I'll double check that. I'm pretty sure I just typed MariaDB syntax, but that's what popped in my mind. Primary key, auto increment, and then we need to give it a name. This will be person ID, so we can work with it. And your database does not have to be great. You don't have to normalize it. You don't have to worry about unique keys. Let's just go ahead and give each person an integer ID. We should probably auto increment it, right? Auto increment. I think no spaces. Let's double check, right? Back to that point, I've taught this in a lot of classes. So auto increment. Oh, it was trying to predict it. SQLite 3. Auto increment, we can see it's one word there. No, it's just jammed together as one word. So instead of 2 words or an underscore, jam it together, auto increment is 1 word. And that way we don't have to worry about the integer. It's just the database handles the row 1, row 2, row 3, and so on in our table. Then a comma, and then we need some other things. So we'll have I just put that backwards. I'm sorry. That was an absent-minded thing. The name goes first. Person ID is an integer that we're going to auto increment. Sorry, order matters. Name first. Then after that, a person's going to have a name, age, and town. That's the class examples I like to go with. We will have a name field, which is going to be text. So if you know databases, you don't even have to worry about varchar. Don't worry about trying to predict how many characters you need to optimize the storage space. Just go with text. It'll give you 255 spaces to put characters and dynamically grow if you're out of space there.
Does varchar work in SQLite 3?
Yes. So yes, if you want to, feel free to do that. But it is I'm not going to dig through the SQL code in detail. As long as it creates tables, as long as it holds data, as long as you can retrieve those data if your project depends on it, as long as you can put data into that table. Oh, by the way, I read through all the projects yet. I haven't responded on them. I've responded on a couple. I usually read through projects 3 times. All of them look good on the first read. I'll read through it a second time, make sure I don't have any questions, and then I'll read it a 3rd time when I put the comments in the gradebook. But tentatively, they all look good. So don't expect any rejections, but after I think about it the 2 more times, I might have some small requests. Or the thing I'm mostly looking for, none of them were too small. The thing I'm mostly looking for and why I think about it a couple times is we are under tight time constraints. In some projects, there might be subtleties that you might not realize would turn it into something huge. So like I'm taking my interpretation of what you suggested the project would be and basically putting the algorithm together in my make sure it can be done in 4 weeks time. Yes. can it be done in 4 weeks time? So that's what I'm looking for. And if I think it's too big, I might ask you to back off a little bit. Never had to ask anybody to make a project bigger, but we are under tight time constraints. So there might be some small request, or if there's something that I think would fit, if it's within the time size, good size, and it's something that I think would be really, really useful to you in the long run as your software development career, I might request an addition there. Like, oh, this is a perfect place to learn this other skill that you're going to use on every third project that you write for the rest of your life. So I might make requests like that. As I think about it more, there might be like some trimming on it, but all the ideas generally look good. If you want to go ahead and get started, I'll be sending out the comments. I'm expecting to tomorrow afternoon. So my plan is when I wake up in the mornings, I wake up at like 4:30 in the morning. I wake up early, do my normal early morning routine, and I was going to read them about 6 o'clock, 7 o'clock, think about it a little bit more, and then around lunchtime is when I was going to send out the comments. That's my tentative plan, but y'all know how plans get messed up. But you should see comments soon, but tentatively they all look good. Okay, got distracted. So we have a person ID that's got a name, an age, which is going to be an integer, and a town they live in, which is going to be text again. And really, for our projects, we're not normalizing it. You could leave off the integer. You could leave off the unique ID, right? We just want the data in there. We're not optimizing our database, so we don't need a unique key. So frankly, that's just kind of clutter in our example, isn't it? So we have a name, age, town, and all that SQL stuff. If you want to include it, take as far as you want, but basically I'm not grading the SQL part beyond works or does not work, right? Because if the SQL part if the database part of your project doesn't work, then obviously your project's not going to work. It depends on the database. So it can be the simplest possible example, no normalization. So we really don't need primary keys or secondary keys or parts of composite keys or any of that stuff. We just need a place to put our data, a nice organized place, so we can retrieve it one data point at a time instead of an entire collection at a time. Then we can run that query. Cursor, if I can spell it correct, execute. Why is it not showing up on that? Oh, well, execute that create query. Nope, not in camel case. Create underscore query in snake case. So let me go to the folder where this is saved. There we go. So right now we just have this one Python script in there. You see on the file explorer on the right. So when I run it, oh, sorry. Let's correct the typos. You all know how programming goes. We run it, fix the bugs. Oh, yeah, that's probably a good place to put this. Delete all this and save this as bug report.txt, because this is the best time to do that whenever you're doing it, right? Write the bug down immediately. Wrong case on module name. And the fix for it was fix the typo. Doesn't have to be super fancy, but that is that and the requirements. SQLite is built in there, so if we save this as requirements.txt, and we don't need to put anything in it. A couple people did do that on the last week. They put like didn't use any modules or something like that. This is for automated processes. This file goes through automated processes, so if you put something in there that it's not expecting, they're going to crash. So we didn't use any modules. SQLite 3 is built into every installation of Python. So our requirements.txt file is blank. It's just to keep those it's just to prevent those automated processes from crashing. Okay. Now we have 3 files in there. Right. So those aren't big, right? Those aren't big asks. Right? I just want you to form the habit of requirements, and bug reporting is standard for the industry and useful in the classroom. So reflection when you're learning, and it also tells me if everybody hits the same bug, then that's something we should probably cover in class. It's like, oh, everybody put the exact same thing in the bug report. Right? That's probably on me from our class example. So it's useful, and it shouldn't be much trouble there. Give that a run, and notice we got a new file here. If I try to open, oh, Spider's going to ignore that file completely. Open externally. It won't even open in Spider. Well, I was expecting a box to pop up and say, what do you want to open this with? But it's not even giving me that. So Spider said open externally, and the rest of the computer said no. Oh, we didn't look at this. So remember how we imported that? PyCache, we look at the type, compiled Python. So Python isn't strictly an interpreted language. When we make classes or when we import modules, they do become compiled code. We do get a compiled version, which is faster than our interpreted version. And that's what's in that PyCache file. We can delete it. It'll create a new one when we do that. Y'all probably seen that before now. But forgot to talk about it. So PyCache is the compiled stuff for imports. In class, here's the database file. If I try to open it here, open with, then it's not, oh, give me the option of Sublime. Sublime is probably going to format that. Let me open it in Notepad. So right at the top, if you haven't seen this before, we always have this, right? Do I have any PDFs here? Again, downloads. No PDFs. Do I have any screenshots? Got a screenshot. Open this with Notepad. Open with Notepad. Y'all have probably seen this in the HTML that shows up, right? The very first line has our type declaration. Same thing in pings. The very first line is the type of document it is. Same thing in a SQLite database. The very first line is the type of document it is. We have a bunch of weird stuff. Notepad++ opens these really well. Maybe I should try Sublime. Documents, delete, examples. Notice how this, I gave the repository a different name. It'll still push back to the repository fine. The name is irrelevant. It's what's inside this hidden folder .git that connects those and makes them the same repository. So we can that ties in nicely to version control. The folders can have different names to help us keep track of versions or who's doing what on the repository. Database. Yeah, notice it noticed it specifically. It knows what it is. I switched to large icons. Large icons. It's a system file, so you may have noticed at some point that things with that icon are all over your computer, especially the ones that came with the operating system. So SQLite is not an obscure thing. Oh, this has so Sublime just opened it in binary. It's showing hex. Hexadecimal is, we're reading binary 4 bits at a time. So I will go back to Notepad. But things are scattered out. There's some stuff Notepad couldn't figure out what it was. Bunch of stuff Notepad couldn't figure out what it is. Oh, it recognized that there's a table called people. We created a table and we did all this. So it kind of recognized it, but all that other stuff in there, Notepad can't figure out what it is the data spots to put our data.
Mine says don't persist. The terminal process failed to launch.
Say that again?
Mine says that the terminal process failed to launch. When I ran.
Sorry, that's why I walked over here. That's a Mac error, not a Python error. Or that's a VS Code error. Fine, we're gonna do. So we'll look at that after class. That is a VS Code error, and I'm not sure where it's coming from. That might take a minute to help track down after class. But we'll look at that after class. There's only a couple more lines, and you'll be able to copy the example. So we can do other queries now that we have that. For those who did database class, you probably remember the insert queries. Right? Probably still have nightmares about insert queries. Insert query 1. Insert into, and well, if there's an ID there, we better skip the ID field. But what fields do we want to insert data into? Name, age, town, the values. And over the years, I've found that if we need quote marks inside of quote marks, we can go one layer deep with the single or double. But it's just best to just go ahead and use the escape sequences. So I'll have somebody named Sally. Whoops. Escape that, and then our closing quote. In the age field, maybe Sally's 34 and lives in the town of Salem. Close the parenthesis. End of instruction. Now I'm going to make a couple copies of that, so I'll just highlight that whole line. Copy, paste, and 3 data points will be enough for our example, right? 2, 3. Let's say Charlie, who's 87 and lives in Charlestown. And Alan, who's 14 and lives in New Albany. There's a couple data, there's some data for our thing, and then just more insert queries, but we probably want to run them the first time and then do them afterwards. Oops. Add a little more space here. Cursor.execute. All right, so at this point we've seen just about all of it, right? Insert query 1. Copy that line, paste it, change that 1 to a 2. You know, have everybody seen this before where we have a bunch of lines next to each other that look very similar, just slight change? It's much more productive to work down the columns than across. This one only has 1 change, but well, this one had 3, right? As we go across, we think about the name, change our frame of mind, think about the age, change our frame of mind again to the age or town. Then the next line we repeat it. We change our frame of mind over and over and over again. But if we go down the columns, we think about names and then handle all the names. Copy and paste it and then do all the names. Then we come to the next column, do all the ages. And we're not changing our frame of mind constantly. So it's more productive to work down than across. And frankly, it's even better to work right to left in that case. Because if you change the stuff over here first, then when you get to the previous column of characters in the text file, they're still in the same place. When we change the name, like Charlie here, push the rest of this back, so the columns aren't afterwards not lined up. So if you work down the columns and go right to left, it can be a lot more productive. This one only has one change, but just come down here to 3 and go copy the line first, and then do all the changes. If we run that, error, syntax error. Where's the error? Execute insert query 1.
Inside to PP.
Oh, thank you. Insert into our people table. Close that. And we'll see it in a moment. Run that. We still got our database there. It existed, but I'm getting ready to address that in a second. Let's open that with Notepad. And don't really see much differences here. Right? It still looks like a bunch of things that Notepad can't make any sense of. But if I open it with Sublime, which was showing it, well, hexadecimal, but really that's binary. We're just reading binary 4 bits at a time. We get a few more things show up. We should. I don't know where I put them. I didn't keep it around.
Here is stuff at the top.
I guess not much, but yeah. Oh, here it is. This row wasn't here last time. So we got more binary there. And maybe it's something else has changed, but it's more than just creating the database. There's something, should be something in it now. If anybody has Notepad++, that one shows SQLite databases really nicely. It still can't register it like Notepad, but it uses some of the black symbols it has, so it shows like null values and it shows keywords.
You can use DB browser.
VB browser works.
Yeah, DB browser.
Oh yeah, VB browser will actually show it as a table. Yes, because I was wanting to look at something that showed the format, so the internal. Oh, let's do a select query. Insert query. Oh, I don't know why I just typed that. We just did the insert queries. Select query, and I'm just going to do a select all because this will probably be good. So SQL is not case sensitive, could be uppercase or lowercase. Using it in uppercase is convention. The words we write are case sensitive. So like if we tried to do people with a lowercase p, that would be a problem. Let's just select everything from people where 1. So 1, it is a 1 or 0, true or false. 1 bit booleans. So where 1 is where true. So every condition is true. End of instruction, and then we can execute that. Cursor.execute. Select query. Oh, well, we should get some data back, right? Means we better put it somewhere. Insert does have a return. Anybody had database class? You remember your return from queries? Do you remember what returns when we run a query on a database?
Which query?
I mean,
Any query, we get the same return. If you use MySQL in your database class, we've seen said MySQL successfully ran query, 3 rows impacted,
Yeah.
17 rows impacted. So we get back an integer,
Yes.
a positive integer, or non-negative integer, because 0 rows impacted is okay, right? Create table, 0 rows are going to be affected, so we get back a 0. But if we get back a negative number, that means an error. So we do actually get a return here if you want to put that and do all the error handling and things. Anything negative, like negative rows affected is an error. 0 and positive numbers, so non-negative errors mean success. But here we're expecting that whole result. So we better put that somewhere. Results is what we get back from that. And then we should get results. Actually, it's better form to close the database before you do stuff with the data. Print results. Oh, SQLite cursor object. So that's kind of like when we print a function. So we got something, but doesn't really tell us what it is. It's gonna be nice if I have to run it one more time. I was expecting that. But let's continue that process. This is the last line of thing we're gonna write. Select in SQLite. This is what y'all are gonna do for your homework, right? SQLite, SQLite tutorial. I haven't seen this page before. That looks nice. Oh, they even got a copy button. Copy buttons are awesome in tutorials, right? We talked about that earlier tonight. Oh, this gets advanced. Where do the results go? Yeah, I was looking for like an example of what to do this. I better put Python in there. That's probably why. Python, SQLite Python. Oh, same page. There we go. So blah, 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 connect, print, rows, fetch all. Oh, there we go. Cursor is select all. Rows is, so we run the select all. That puts it in our cursor, so our cursor can see a whole bunch of stuff. So that's why I was using highlighting as the example. We just highlighted a whole bunch of stuff. Then we fetch all and put that somewhere, loop through it. Make sense? It's fairly straightforward. So results don't go here. Our cursor sees something. Hopefully it sees something when we run that query. And then we can say data equals cursor dot fetch all. Fetch everything that's in that query. And this is what I usually do in code. A lot of times I'll start with the select all. So frankly, that would be fine for your project. If you have the data there, select it all and then do selection structures in Python, because we're actually studying Python in this course. This is just something that often accompanies Python. And now that we have that, so for D in data, print D, which I think we need to take that a step further. Oh, I just pointed out that it's best to do it after I'll leave it there. Oh, something went wrong. Took a minute. Database is locked. That's weird, right? Kept going and compute, execute. Database is locked. That tutorial still open. That looks exactly what they did. Grab our cursor, select everything, run our fetch all for all the runs. Look at the next example. It's the same thing. Sort ours time out and keep going. Any thoughts?
What if you remove the data equals the cursor and just print cursor that fetch all?
Oh, good thing to check. So let's do print cursor dot fetch all. That's not really what I was going for, but it's a great thing to look at here. Goes in there. It's taking a long time. This database is locked. Why is it locked? It's an odd thing for it to happen, right? Our script creates a new database. So let's delete the database that exists here. Something's using it.
Sublime.
Probably. No, Sublime's not using it. Notepad using it? Well, Notepad's not using it. Something is definitely using this though. Let's close this console, make sure it's not Spider still trying to use it. Oh, the console don't want to close. There it goes. That was probably what was using it. Oh, spiders froze up. I'm not froze up. There we go. So that's what happens if we say print all. Do you see it, Santos? That was a great question because it makes sense, right?
Yeah,
For
I see
sure.
what happens.
Print all gave us an empty list. But we should be able to loop through that list.
Why did it give us an empty list?
Why did it give us an empty list? So, data equals that. At the end of that line for,
Wait, what did you put there in select point?
oh,
Where people were what?
select asterisk, so wildcard, everything.
Yeah, from people where
Where one, so that's where true. All conditions are met. So that's the same as writing where true, but SQL uses a 1 or a 0 for true and false. For D and data, print D. Worked that time. Got a bunch of tuples, and you can see they came back as tuples. So each row is a tuple. So we can make a sentence out of that now that we know what our data is. D index 0 should be the name.
so it's a tuple of tuples.
Plus is plus D1 is the age plus years old, and we have to come back and cast this. Oh, old and lives in quote, then plus D index 2 should be the town. And this one is a number. Should be an integer. Save. And we get some nice sentences formatted nicely in sentences. That's about what I'm expecting you to do from a database. I'm not expecting a whole heavy lot from a database, but that's what software does, right? Software processes data. That's what we need it from. So we do have to put the data somewhere and then select the data, and you can do your filters here. You just do a select all, but we could abbreviate that. Let me comment this line out. And maybe we just want the name. Select name from that, and then if we say print D, our results are going to be a little bit different, right? We just get the name. So we can filter it down. Set select name from people where age is greater than 30. I think there was at least one of them, right? So Sally and Charlie are greater than 30 or less than 30. Run that, just get the one name. And yeah, notice it's still a tuple. It'll always come back as a tuple. A list of tuples. I'm going to go back to the select all query because especially for class when we're under tight time constraints, just doing select all, and since we're actually studying Python, doing if else to filter it here is fine. Put it to some useful words and stuff. Any questions about that? So the SQL homework is still going to be pushed back because your book talks about something called SQL Alchemy. SQL Alchemy is a module that allows us to use Python syntax to manage your relational database. In particular, a SQLite database. We can use SQL Alchemy for other relational databases, but it takes some finagling to get all our connections and stuff because it's made to go with SQLite. But the tutorials, those follow along video tutorials on the homework this week, those use SQL Alchemy, so you'll see it there. Our textbook describes it. It's Python syntax. There shouldn't be any surprises with it. So some feedback. Do y'all want me to push back the database example? Or it's basically this And if you want to skip SQLite, or not SQLite, definitely include SQLite. But if you want to use SQL Alchemy to use that, or if you want to stick with SQLite and skip the SQL Alchemy, I am fine with that because I never use SQL Alchemy. I never use it, and every time it comes around to teaching this class and grading that homework again, I have to think really hard and then start doing some random practice things to get used to SQL Alchemy. Or before it shows up in lecture, I have to do some random practice to get used to it. I never use it. So if you want to skip that and just use regular SQL syntax right in SQLite, that will be fine. I will accept the assignments either way, because there are also reasons why Python programmers like SQL Alchemy. And then they only use the syntax from one language in their program instead of two. Beneficial. Oh, and one thing about that assignment, it says like whatever chapter it is, maybe it's not 6, but it says like do 6.8. But assignment 6.8 depends on 6.5, 6.6, 6.7. So it just says one of them, but that depends on the previous 3 questions, or however many it is. It's obvious when you get to the book, and there's not very many of them. Oh, yes, somebody just put it in the chat. Thank you. Renee put that in the chat. So yeah. 6 sections. I don't think you need all 6 of them. So when was the last time I taught this? That would have been September. Oh yeah, Ezra got it narrowed down to 3. So I believe 16.1, 5, and 6 are enough to do part 8. But for general practice, 1 through 7, it builds on the previous one. Otherwise, that was it for tonight. Do y'all want me to push that assignment back? Because right now we covered this, so it's going to stay like it is. But SQL Alchemy is not covered, but there's good reference material for that. And this week's homework, a follow-along tutorial, and the book. And we'll look at it Monday. If you have there's time to answer questions before it's due. But we've seen the rest of it. Does anybody want me to push it back explicitly? I see shrugs. It's probably okay. Because if we don't push it back, then that'll put us back on track with the due dates, and we'll have to keep changing due dates further along. Did that error fix?
My laptop died.
Oh, that's a VS Code error.
I'm sure I did that.
I have no idea why I did that. VS IDE errors are way harder to debug than our software errors.
Maybe I should have put absolute path instead of relative path in terms of writing data to be
Like that, yeah.
that can happen in X.
Yes, because especially VS Code is running someplace different. I saw CWD, current working directory, in there, so it might.
Yeah.
It doesn't know which current working directory you're in because it's got a couple of them going at the same time. So try the addresses.
That's what I needed to do in my C++. That's what I did.
Yeah, it's better for them if you're on that computer, but when you start moving things elsewhere in the world, absolute addresses get problematic. But yeah, try a relative address. Is that what you said? Did you do relative or absolute?
Relative is /user/.
That's absolute. So that's the entire path. It's absolutely there on your path.
I
Relative is like starting from this file, where do we go? It's like dot /
just put the name in
up to the parent and then back down to the next one. Just put the name, that should be relative.
Yeah.
So you might need absolute.
So do we
Which
still get a data class per credit?
in Python is __ file.
What is that?
That's where the file you're running is located. That's your absolute path to the file that's currently running. So then you have an absolute path on whatever you're running. We'll look at that Monday. And you can type it into your examples. But there's a way right, like we have main. File is the file that's currently running, whatever we call it.
And
So we can always grab the absolute path that way.
where do you type that?
So use that
Where do I use that?
as the first part of the address. So
I use it in the interpreter.
so in your thing, so __ file to get absolute path. Python. Oh, there it is. I didn't see Python on the list. So notice that's also it also shows up in a whole bunch of programming languages. Yes, so we use file. Okay,
So
that's,
put that in the interpreter.
in your code.
In my code.
So, so like here's typing in the full absolute path, or they use the absolute path. I used to use a file. There's lots of ways. If you just look for how to get absolute path, it's probably better than typing it in. Because when you type it in, it won't work on my computer. Actually, never mind. If you type it, if I see an absolute path in your homework, I'll change it to my computer. But there is a way to actually get the absolute path. I always use file. Oh, there we go.
If you use underscore file underscore,
Yeah.
then
That's your current, the
Then-
current file that's running.
I mean that would work in any computer.
Ah, here it is. os.path.basename file. That's your absolute path. So underscore file is the current file that's running. So we just use the operating system .path to get the, oh, not base name, directory name or absolute path to it. Or this looks easier, pathlib.path.absolute path. Lots of ways, but you probably want to look into how to get the absolute path instead of manually typing in the one for your computer, because when you submit your homework, that's not going to work on mine. And there's going to be one, and I completion graded last week, so this week's not going to be completion graded. I'll completion grade one thing every other week is my policy for that. I'll go ahead and tell you that. So I don't keep it a surprise. And I still read every line of code you're writing at completion grade. All right. Any questions about this? I should upload this to the repository. I'll give 5 seconds to. Oh, real quick before we do this. So, Get GUI is still open. So I want to rescan. Oh, here's unstaged changes. All these files have changes. Some things removed, some things added. Green and blue is kind of obvious. That looks good. So stage those changes using like theater terminology. So now it's backstage. Sign off just puts my name on there. I'm going to jump ahead to the commit. We need a commit message. So this was objects and databases. And then a longer commit message, and then stuff in the footer. We can actually carry out actions from what's in the footer. I'll commit to those changes. We do have to have at least one line for a name. And notice commit is like, well, using the stage. Stage is backstage. Commit is the curtain goes up. There's no going back once the curtain goes up. Push those changes back to the origin, remote origin, main branch. That looks good. So push those back up. So you can see this, the Get GUI that comes with it is a nice, easy one to use. There's not a lot of functionality as opposed to that other one that I kept opening. Probably should have started with this one, right? And we get a nice big green success. Okay, so any questions? Okay, that went longer than I planned, but I'll give it a few seconds. Give people time to unmute or start typing something in the chat room. Okay, I assume if there's no questions in 5 seconds, then there's no questions. If you have any, let me know. I'm always happy to help. It doesn't have to be in the next 45 minutes. Send me questions anytime. Send me questions at 3:30 in the morning. It won't bother me at all. If it wakes me up, I'll answer your question. If it doesn't wake me up, I'll answer the question when I wake up. So feel free to reach out anytime if you get stuck or anything. Y'all have a great weekend, and I'll see you on Monday. Good. See you Monday.